Welcome to DB Workshop channel. If you haven't subscribed to this channel, please subscribe it now. Today we will discuss few concepts on operating system. The topics we will discuss today are kernel IO, DMA, network-based IDS, host-based IDS, network OS, distributed OS. If one or more devices use a common set of wires to communicate with the computer, the connection is called bus. Bus is a set of the wires and a rigidly defined protocol that specify a set of messages that can be sent across the wire is called bus. When device A has a cable that plug into device B and device B has a cable that plug into device C and so on, finally it is plugged into a port on a computer, this arrangement is called daisy chain. As per this picture, you could see that a SCSI host adapter having two examples. One is external chain, another one is internal chain. These are daisy chains. The controller is a collection of the electronics that can operate on a port, bus, and device. IO port typically consists of 4 registers. For example, status register, control register, data in register, and data out register. For example, data in register is read by host to get the input. Let's discuss few concepts about interrupts. CPU is, for example, CPU is doing something, and if you press a key from your keyboard, then there are two ways to tell that CPU is need to be given a priority on a stuff. So there are two methods. One method is polling, another one is interrupts. So polling means CPU continuously run in a loop and check for each hardware device that CPU suspend its own stuff and do the request if it is coming at any hardware device. If it found any request on any hardware device, it load and run the software and fulfill the request. Once done, the CPU goes back to on stuff and start the polling again. So here the concept is busy wait cycle. That means waiting for IO from a device. These days modern hardware uses interrupts. Polling is no longer uses. Most of the times hardware devices are using interrupts these days. Interrupt handler determines the cause of interrupt to perform the necessary processing and execute a return from the interrupt instruction, and then return the control to the CPU and let it do whatever it was doing it earlier. So hardware mechanism that allows a device to notify the CPU is an interrupt. And one more point regarding device driver, that it presents a uniform device access interface to the IO subsystem. For example, it can do a system calls to provide a standard interface between application and the operating system. Interrupt is also called CPU has a hardware that has a wires, and we call it a interrupt request line that CPU can sense after executing every instruction. Let's discuss more about what are interrupt request line. It is a connection between the hardware device and the CPU. Hardware device uses its IRQ line to signal or interrupt the CPU. Interrupts has a priorities. For example, a CPU is running something, for example, virus, antivirus, or maybe virus checker, and you decide to drag and drop a file. At the moment when you do drag and drop a file, then there will be an interrupt generator, and that interrupt will go to the CPU, and CPU suspend its own task, whatever it was doing. For example, if it was doing virus checking, so it will stop that process and try to fulfill the file drag and drop operation. Meanwhile, when it try to do the move operation for file the moment some key is pressed from a keyboard, because there is a high priority for keyboard, and so even the file operation will be paused, will be suspended, and it will fulfill the request whatever it was from keyboard. After processing that request, it will give the control back to the file operation, and once that will be completed, the CPU will return back to the previous running program. It was virus checker. The next, let's see an example. Intel interrupt controller IC. For example, in a motherboard, there is Intel interrupt controller IC, and it provides these 8 request lines, IRQ lines. Many devices such as a keyboard, disk drive, printer, uh, each has a IRQ line assigned to it. The interrupt controller then activates INT signal to the CPU. The CPU acknowledges the interrupt and lowering the INTA signal. Once it lower, it has to enable. It has to place the IRQ number on the data bus. CPU uses the IRQ number to jump to the device service routine in the memory and begin executing the code. Here's the example. These are the IRQ numbers, and these are the IRQ lines. So this is just a modified version having the 15 IRQ lines. So next one is the 2 interrupt request lines. There are 2 types of interrupt request lines. One are the maskable interrupts, and another one are the non-maskable interrupts. So maskable interrupts means these are the used by a device controllers and can be turned off by CPU before executing of critical instruction sequence that not to be interrupted. Non-maskable means reserved for events, for example, unrecovered memory errors. Interrupt vector contains memory address of the specialized interrupt handler. Next one, devices. You could have a 2 type of the block devices. One is a block device transfers, for example, block by block copy in a disk drives. You could have a block by block copy, where the character stream devices transfer are the byte by byte transfer. These are called keyboard. Another one is the data transfer, that are called a DMA to be used. Dedicated devices is just opposite to whatever we call shared devices. A different way to intrude maybe buffer overflows, unexpected combination of unhandled input like a SQL example and race conditions that may intrude the system. So characteristic of host-based IDS, like a host operating system logs and audit information. It also audit what are the logins, what are the open files, what are the program being executed, what are the drawbacks of host-based intrusion detecting system, because it is unselective. If you do the unselective logging of the messages, it may increase the audit burden on the system, and it may in turn fill your disk space. On the other hand, there are some good points about a network-based intrusion detecting system. They look for the signature in the network traffic. What happens in network-based IDS, having some kind of a library, and library knows what kind of threads and what are the signatures of those threads, and it has that library. Once any packet is moving across the network, it just inspect each and every packet and match it with the library packets. If the signature is matching with the library packets, it just flag it and send the alerts, maybe using pager or SMS or email, whatever the IT admins has or network admin has configured it. What are the strengths of host-based IDs? It can do the attack verifications. It can do the system specific activity also. It don't require any additional hardware software. All it need to do is just monitor the system logs, the data files, and try to see if there is some suspicious or malicious activities going on there. What are the plus point for network based IDs? These are the, the cost of the ownership will be reduced, and malicious intent detection is also done, and it is a real time. We could detect it and we could do the remedy also, so response is also there. Intrusion detection system is made of three parts. One is a analysis engine that simply analyze whatever is going on over there. Event provider, I mean, it just trigger the stuff on based on events and alert database. It just maintain the database of the uh, alerts. Drawbacks, what are the drawbacks? It cannot detect the novel attacks. It suffer from the false alarms. It could generate so many false alarms. It needs to be programmed against for every new pattern detected. What are the characteristics of signature based IDS? Based upon a system, based on a simple pattern, it works on a simple pattern matching algorithm. What are the drawbacks of anomaly detection system? They generate many false alarms. Characteristic of anomaly based IDs, it it models normal uses of network, and it just do the noise characterizations. Let's study more about this. Anomalies intrusion detection system, detecting both network and computer intrusions, misuse by monitoring the system activities, classifying it as a normal or anomaly. So classification is based upon some kind of a heuristic or some rules. So it uses some kind of artificial intelligence, and it sees that what kind of anomalies could be there in a system. So based upon those rules, artificial intelligence heuristic approach is being used, and based upon that approach, it just uh, creates some kind of a patterns or some kind of a signatures, and identify that these rules will be mark the packet as a, or the log message as a anomaly, and mark them as a flag. Otherwise, if that pattern need to be revised again and again, and system need to be trained. So first of all, if when you set up a new system, that is a baseline is created, and based upon that, it would have no patterns or no signatures, but using the AI heuristic approach, system will be get trained, and based upon those trainings, some rules will be generated, and it will have some kind of library of patterns and signatures. Those patterns and signatures will be used to identify the anomalies. Those anomalies are being used to flag the suspicious activity or anomaly, or malicious kind of activity, and that's the concept over here. So each type of IDS employ either a strategy which gives certain advantage. Choosing between host-based IDS and network-based IDS, maybe anomaly or a signature-based detection strategy, are not mutually exclusive. You could use both of them. It is not that once you use one method, you should not use another one. You could use both of them based on your requirement. So signature intrusion detection, it is just a method where you just detect the attacks based upon the signature you have previously created over there. So how is that possible? Because it has its own database and its own library. Based upon those library, it just match each and every flowing packet through the network and match with the library. If that match happens, it just flag it. Anomaly based detection looks for unusual or irregular activity caused by user or processes. If your network was accessed with the same login credential from the several different cities across the globe on the same day, it could be a sign of anomaly. So it just to flag it. HIDS using anomaly based detection like service log file. It just service the log file, it read the log files and see the if it has a unexpected behavior, whereas NIDS monitors the anomalies in the real-time network by looking at the packets. Signature based form of detection monitors data for patterns. HID running signature based detection work somewhat similar to antivirus application, whatever the antivirus application is doing, because antivirus application would already know the what kind of viruses are there, what kind of the suspicious patterns are there, so it just match those patterns. It has its own database. As you know that antivirus need to be updated daily, and it automatically keep on updating based upon the new learning the antivirus is doing. So those updates has to be run to keep the system safe. So it use the same concept. HIDS running signature based detection is just work on the same concept whatever the antivirus applications are using. Signature based NIDS on the other hand is more like a firewall. Whatever the firewall is using, firewall has a certain keywords, certain packet types and certain protocols. It allows inbound and outbound uh, calls to be allowed on specific ports. So signature based NIDS could be compared with a firewall, whereas HIDS signature based detection could be compared with antivirus. Host based intrusion detection system is just a host based. It just keep on monitoring the computer or a network for a suspicious activity. It just read the system logs, because as we know that every application is just writing the log files. It just keep on reading the log files, and it just, if HIDS is not there, it would be very bulky to read those thousands of the lines from the log files, and it could fill the system, and it is just too much of difficult task to be keep track of. So host based intrusion detection system solve this problem. HID monitor the log file and that are generated by the application, and just it keep the historic record of activity and function. It could quickly search the anomalies and signatures in signs in the intrusion may have occurred. They may also be compile your log files and let you keep your organized in such a way so that it would be easy to handle. It is an automatic process, so it makes the life easy for administrators. HIDS use the rule or policies, for example, to search your log files, flagging the events, and determine what could be the potential malicious behavior. So IT administrator IT admins are most familiar with the system operations, so they have to create the rules, and these rules must be written by some security experts who knows more about what are the possible threats to the system, and these policies has to be updated frequently. Even I would say that it has to be updated uh, real time, uh, hourly basis or maybe on daily basis, so that your system knows the threats in time. Next, host-based intrusion detection system. It is a keeping the strong line defense against the hacking threats. HID monitors the traffic and suspicious activity on the specific computer infrastructure. On the other hand, NIDs are network-based traffic activities. Both systems work by serving the log. I'm looking into the log files and event messages, but the NID examine the packet flowing through the network. NIDS works more in a real time and tracking the live data, and it is just see for the signs of tampering. HID check the log files evidence for the malicious activity. A solid security setup would have a HIDS and NIDS. Both are needed, so looks like these are complementary to each other. NID allow for us faster response time and potential security threats, and the real-time packet data monitoring can be done. HID allow you to examine the historical data for the pattern of activity. For example, if you have a computer system and you have HIDS set over there, so that means HIDs take the snapshot of a system on a particular intervals. It would have a good baseline the moment when the system has been set having the no activity at all, that kind of and stable system activities. All these snapshots are being compared to see if there is a something change in a pattern. So it just analyze the historical record. Based upon those records, it just can suggest and flag the suspicious activity. Network based IDS, it just scan the network packets at the router or host level, auditing the packet information and logging any suspicious packet into special log files with the extended information. Based upon these packets, network based IDs can scan its own database and check if it is if the signatures are matching over there, and assign the severity level of each packet. If some packet are being marked as a severe packet, it just have to send a alert or warning or cellular pager to be the security team, so that security team members can investigate and see the what kind of the anomaly is there. Network based IDs have become more popular as the internet grows in size and traffic. IDs can scan huge amount of data and successfully tag the suspicious or suspect transmissions. Due to inherent insecurity of TCP/IP protocol, it has become very important for developers, scanners or sniffers and other activity auditing detection tools to prevent activity over. For example, if you just run the command if config on a particular device, you could see that there is promiscuous mode is on or not. What that means? It means that most of the network-based IDs require a host system device to be set promiscuous mode, which allows the device to capture every packet passed on the network. By default, this mode may not be enabled. To make this enabled, you have to run this command if config it0 promise. By running the if config command again, you could see that this feature will be enabled, so that every packet on the network would be captured. So device to capture every packet passed on the network. So this command will work on the Linux or Unix operating system. On the Windows 10, this you have to run the different command over here. For this, you have to run this command netsh bridge so adapter, and there, for example, your NIC network interface identifier, if your identifier is 1, then you have to run this command netsh bridge set adapter 1 force compat mode enable. What happens then if you have a bridge? Then this settings by default will be disabled. So you have to run this command to again enable this. To do this, you have to open, we are talking about a Windows 10 and you are using the network bridge. If you are using Windows 10 and using the network bridge, by default this feature may not be enabled. How to re-enable this? You have to open the command prompt using shift control enter, and you have to launch the command prompt using elevated privileges, or what you can do is just navigate to the command prompt and write it and open it as a system administrator. So with the elevated privilege, once you open the command prompt, you have to run this command netsh bridge so adapter. It will show the adapter being used on the bridge, and once that will be shown, you have to see what is the network interface ID for it, NIC ID. If it is, for example, if it is 1, it may be something else. You have to again run this command netsh bridge set adapter 1 force compat mode is equal to enable. So it will enable the promiscuous setting, so that every packet going through this adapter would be analyzed. It will capture every packet passed on the network. Next, direct memory access. It stands for a direct memory access. DMA is a method of transferring the data from the computer RAMs into another part of the computer without processing it. So many times you just don't need to process the data. You simply uh, have to route. You simply has to send the data to the device. For example, if you are talking about a sound card don't need to process the data to be get processed by CPU. It simply send the data to the sound card, and sound card knows what to do with the data. CPU does not require to be disturbed by this activity. What happens using DMA, you can directly tell that this is the computer's RAM area, and that can be redirected to the sound card. And using DMA, it could bypass the CPU stuff, so CPU don't need to interfere in this activity. It can simply may use the DMA to bypass the CPU. For example, same with the video cards. Video cards that support a DMA can also access the system memory and the process graphics without need the CPU. There are few more examples for this. We discuss now kernel IO services. For example, IO subsystem protects itself from the malicious processes and malicious users. IO scheduling. So these are the kernel IO services. So IO scheduling is something IO request to be run. Application will issue a system calls, and the order in which these IOs to be run. So this is all done by a kernel IO services. Buffering is another example where the memory area is buffering means it is a memory area between two devices, between the one device and the application, or maybe between two devices. Buffering helps in the speed the mismatch between producer and consumer. It can solve the different data sizes issue. For example, if application is using a write system command, it do the simply translation. It helps to understand that this data needs to be written to the disk. So buffering helps in doing the translation of system command, for example a write command, to get it written to the disk. So this is enhanced done by kernel IO services. Caching is a fast memory having copy of the data, but it has to be put it on a faster storage, otherwise it won't work. So spooling and device reservation. Spool means a buffer that holds the output of a device. For example, if you are using a printer and printer cannot accept the interleaved data stream, so what will happen? Because printer is a serial device, it can process only one jobs at a time, irrespective of the fact that there are many concurrent jobs are running in a computer and needing the printer at the same time, but it just maintain a queue over there. So spooling helps so that a printer can just get the continuous data. So another one is error handling, that is also kernel IO services, and IO protection is also kernel IO services. Next one is a network operating system. Network operating system means multiple computers on a single computer, used to manage multiple computer from a single computer. Distributed system must have a transparency, fault tolerance and scalability and clusters. One more thing, the network IO is loosely coupled system having different type of the systems. It is a two-tier architecture. It could be a peer-to-peer network operating system. It could be a client-server architecture kind of a network operating system. So it could have a different operating system. It have a very less fault tolerance, and resources are handled at a local level. It is easy to implement. It has a low transparency. On the other hand, a distributed operating system, these are the tightly coupled systems having similar computers. It needs to have a same operating system. It could be of entire shared memory messages used for communication. It has a global resources. It can help in, it actually does the distributed management. It is very tough to implement. It has a high transparency, and each processor has its local memory and clock. Distributed operating system are tightly coupled, that means software, and loosely coupled, that means hardware. So hardwares are loosely coupled while softwares are tightly coupled. Next is semantic models. You could have a three type of the semantic models. One is Unix, another one is the translation, and next one is session. So when we say the translation, when we say the transactions semantic model, that means the transaction semantic models. For example, if you're talking about sharing the files, for example, we want to lock the files using some kind of a locking mechanism. We are talking about the serializability. So that means we are using some kind of a locking system over here. So this semantic model tells that you could lock the files, you could share it for read, and you could have a exclusive lock for writing. Same concept for a database also. For example, some records or some disk block or some tables or some row in a table could be in an exclusive shared lock, or could be in an exclusive lock, or could be in a read. If it is a read, then everybody can read it. Unix semantic model, that means it is easy if it is a single processor. For each processor, data is cached and write through a cache control. Write back enhancement, it is help for a performance. Update are written only to single copy and that are available immediately. Next one is a session semantic. This just does for file share. For example, if you want to share a file, for example, you have to copy the file, you have to open it, and you work on the local copy and copy it back on and close it. So that means you create a session, you do your stuff, and you whatever changes you want to do, you do it, and you again submit it. You get it, you do the changes, and again you submit it. So that is a session semantic model. Transaction means concurrency at the transaction level. Session means you maintain your own session. And Unix semantic model, that means a single processor. So for each process the data is cached, so it is on the process based, and update are written to the single copy are available immediately. So we have discussed these topics over here: kernel IO, HIDS, NIDS, and distributed operating system and network operating system. If you like this video, please subscribe. Thank you.